This is Chapter 8, Part 2, where we left off on the basic operation of one-dimensional arrays. These are the basic things that we're going to start out doing with. Each operation requires an ability to step through an element in an array. This is very important. You can't, when you actually have a list of an array, I'm going to refer back to the spreadsheet. You have a list of a one-dimensional array. You have to either you write to it or you read for it, but you have to go from one element to the next element by writing a loop with this thing. And the loop that's most commonly used in programming for array are for loops with this thing. So you're going to use some of these for loops that you're going to process each of the elements inside of the content of the array that you have. So in here, that's what that means with it. You can't process it by an entire bulk. That's my point. Okay. So tailor this thing. If an int list array is size 100, meaning array size is 100, and you're going to initialize it to I as an int, you're going to plug in, here's your I, and then you're going to plug in I here, which is what, 0. 0 is less than 100, which is true. You're going to actually store in list 1, meaning list starting with 0, element 0, element is going to, and then it's going to increment, post increment after this. You see what I'm talking about? So you're going to see how it actually post increment after with all of this. The other thing about it is an array index out of bound. If an array index is out of bound, okay, if the index is greater than or equal to 0, and if it's an array less than the array size minus 1, otherwise the array is out of bound. So think about what this definition just said. Think about this definition, what this just said. If I have an array size 10, right, that 10 is greater than 0, and the size is always what, 10 minus 1, and the array element index is going to be 9. That's what that's saying. Okay. Otherwise, if it's not, it's going to be out of bound. In C++, there's no guard against indexes that are out of bounds. I just want to give you a heads up with that. Okay, so there's nothing that actually protects it from going out of bounds with this thing. Take a look at this thing. How do you initialize an array? An array can be initialized during declaration. Value be placed between the curly brackets. Size determine the number of the initial value of the braces. So take a look at this number right here. So this is, I'm giving an array size, sales is the name. The data type of this array is double, and inside of this is element 0, element 1, element 2, element 3, element 4. Okay, so but it doesn't, I didn't give it a size, but I can actually declare a certain size in this array with it. Take a look at this. A partial initialization array during the declaration. Well, what's that mean? A partial one would actually, the statement declares an array of 10 components and initialize them all to 0 with this thing. So here's something that I can actually give all the elements here and initialize it to 0. Look at this. If I have a size of 10, here's what the first 3 is going to be. So declaring a size 10, I have 0, element 0 is 8, element 5, element 12. And the rest, all the others, going to initialize it to 0 with it. Okay. Irrigation operation. Any operation that manipulates the entire array as a single unit. You can't do any irrigation of the array in C++ with it. So don't have to worry about this. But irrigation is, in real life, is when you have one field or one attribute in another field, a class inside another class, and that class affects the field of the other class. You don't have to worry about that in C++. Here's another example. My list 5 is an array, and I have in here, I have 5 elements, right? So line 1, so how would I process this thing? So here's 5, 0, 1, 2, 3, 4, and I have 5, size 5. So I can't do this. I can't set my list equals your list. I can't do this. This is not allowed. So this is an example of irrigation. what you have to do is read through one by one of these things by setting it equal. So here's my list, and you're going to set it equal to your list, but you have to loop it through the individual indexes as you do this thing. Okay, so that's how you do this. This is improper, this is legal. The bottom one, solution, is legal. So that's my point in that. Array you can pass as a parameter to a function. Array are passed by reference only, meaning reference parameter. So you don't have to use an ampersand to declare an array as a formal parameter. Size of an array is actually omitted. So if provided, it's ignored by the compiler. For example, if you look at this, again, you don't have to put the ampersand, but they know this is a void function parameter, and the moment you use these square brackets, it knows it's an array that you're going to pass in list 1, list 2, and through this, as it's going to come across as a reference parameter with this. Constant array is formal, can prevent a function from changing from an actual parameter when you're passing the reference. So using the const in the declaration of a formal parameter in this thing. So as you can see, here's where you can actually pass as a formal constant of y in this, and this will come across as a constant parameter in this thing. Base address of an array and array in the computer memory. The base address of an array, address memory location of the first array component. If a list is one-dimensional list, its base address is defined as list element 0. When an array is passed as parameter, the base address of the actual array is passed to the formal parameter. So what this is saying is that you're passing in as the memory address of this, whatever the element is, that's the one that goes through the memory address of the formal parameter that comes across it. C++ cannot return a value of type array. So C++ does not allow functions to return a value of type array. So what does this mean? You can only use reference address. If you recall, reference address allows you to actually return more than one reference address across with it. It's like a void function with this thing. You cannot use a return and return an array after you pass it as a function with that. Okay. Here's another one: integral, data type, and array indexes. And the C++ allows any integral type to be used as an array index. Improve the code readability with this thing. Remember the enum? You have paint type, green, red, blue, brown, white, orange, yellow, and then you have your array size of 7. So I'm going to run this. If you look at this, this is what? Green, is element is 0. Paint is going to start out with 0, assigning 0 to it. Paint is 0 less than or equal to yellow. What's yellow? 0, 1, 2, 3, 4, 5, 6. 0 is less than or equal to 6. True. You're going to come down here, you're going to plug in paint here is what? Paint is green is 0. 0 plus 1 is 1. You're going to convert that, this is an expression, convert that over to paint type, right, is equal to red. Okay, because it's 1, it's going to convert to paint type as red. And then you're going to actually pass in the paint in here as that 1, that 0, you're going to paint that sail with it, so you're going to plug in the red here, add that to the 75.69, and that's going to update your paint sail red. So that's a type how you can actually see, you can actually use static cast and some of this stuff. Constants int, number of students, 20. Test scores. You have the int array as number of students, so this 20 now is being as a constant sitting in here with it. You have your int identifier as 50. Remember this, type dev, double, list size, your list, and my list. So you can use this list right here is the array size of your list and my list. This becomes the data type of that is. Okay? So we talked about this in chapter 7 in here. This is a good point. Let me stop right here.